Okay, so generally I'll put I'll put everybody's phone on mute so we don't get background noise. That usually helps with audio quality on the recording. So as we move into it, raise your hand, that'll give me, or chat me, and that'll give me an idea that you have some questions. Okay, so we're going to start off going through our discussion about Maven. In particular, you'll see in this topical list, there are a bunch of different things that we would cover in our traditional 2-day course. We've kind of streamlined the content, so to speak, to cover the key concepts that you'll need to know to get started. We're going to start off generally with an overview of what Maven is, just some context to the product. Then we're going to move into a discussion about working with Maven. We'll go through some key commands to help you work with both plugins and lifecycle phases. Then we're going to jump into some of the more meaty concepts, like what is the POM and what does the POM look like, how do you customize the POM, so on and so forth. And then we'll end up with a discussion about properties and working with web apps and working with some dependency pieces. So that's kind of our core today. We're not going to get into multi-module projects. We're not going to get into what I would call optimizing the POM. That content is in the book, so if you want, feel free to look at that on your own time. You have my email address, so if you have questions, at the end of next week or sometime, feel free to email me, and we can set up a half-an-hour conversation and cover those if needed. But that's going to give you kind of a quick rundown of what we're trying to cover for today. Again, we basically have 4 hours starting now, so it's going to be a bit of a brain dump. I'll try to make that not super painful. We will try to do some breaks for some labs. After each section, I'll quick just ask to see if you guys have any questions. And then at the end of it, obviously, if there are questions after you do the little labs, we can talk through those as well. So let's just about kind of the background. Background for Maven really is pretty easy to understand. Ant, as Java developers, we're probably all really familiar with Ant. And Ant, in its loose definition, is what I would call a build script tool. It's not really a software project management tool. In other words, it's not really designed to manage the artifacts that are associated with a software project. Ant's not really created to manage the test-driven development aspects of my project, so on and so forth. So Maven tries to be a much more comprehensive, kind of all-encompassing software project management tool. And a little point of clarification there: we're not really talking about software project management from a PM perspective. Really, just from a root source code, text files, properties files, things like that perspective, along with what I would call the life cycle of my software project. The big thing for those of us who are new to Maven from some other build tool, the big thing is that Maven assumes some level of intelligence. And the idea there is that if we were to survey 100 Java projects, or even more specific, 100 web application Java projects, we would be able to start to identify some trends within those projects. And based on those trends, we could apply some intelligence that said, hey, you know what, 80% of the projects look like X, Y, Z. So Maven's tried to apply that intelligence, they call it patterns, but that intelligence to the most common types of Java projects, whether that's a war-based project, an EJB jar-based project, an EAR, a plain old jar, whether that's using OSGI or Hibernate or JPA or Swing. There are a bunch of what Maven calls archetypes. We would call them templates to define those project structures for us. The key thing there is that as a developer, I don't have to worry about creating the project structure, organizing the project structure, or all the interdependencies within the project structure. Again, Maven, through its quote-unquote intelligence, has that kind of figured out. So we're going to say that Maven is an automated build tool. So it's going to be kind of like Ant in that perspective. It has a couple of different focuses. One is the creation of a project, and again, that's kind of the stuff that I talked through just a second ago. You know, making sure that I have a source tree that's in the correct location with the correct name. So that's a creation piece, and then the management piece. Management, obviously, interdependencies within my project, but then also management with external projects. So whether I'm using JUnit as a library or whether I'm using Apache Commons as a library in my software, it'll do the dependency management for me. There is a term in the software development community right now, Application Lifecycle Management, or ALM, and there are a bunch of different tools that you can buy or license to help you with that. Maven is kind of a loose implementation of a application lifecycle management tool. It takes on kind of the build-oriented phases, so it's not going to deal with requirements gathering. It's not going to deal with kind of post-release maintenance. It's really in the heart for me as a developer as I'm building the code, testing the code, and then releasing and deploying. So it's not maybe as full-featured as some of the other off-the-shelf products, but it's, again, not really trying to be this huge ALM tool. It's really built to help developers. Quickly, a little background on Maven. It's been around for a while, 2001, so it's nearly 10 years old. There's some key sites there. Maven.apache.org is the primary site to go through. The Sonatype website, I would call it kind of the commercial open source type of business model for Maven. They do have a number of public reference books that you can access. In fact, if you were to go buy, Maven by example through Amazon, it's exactly the same as the Maven by example published to their website. So you save yourself $50 or whatever, and just hit their website. As far as the kind of goals of Maven, kind of mentioned these before, but let's just formalize them. The first thing from a simplicity perspective is that Maven believes all projects are going to have some project focus, meaning I'm not just going to create a single piece of source code and call that an application. More than likely, my application is going to be comprised of multiple source code files, multiple configuration files, multiple external resources, whether those are jar libraries or image, things like that. So it's very project oriented. Coming from an IDE, that mindset will fit really well. In other words, if I've been using Eclipse to build my source within Eclipse, or I've been using NetBeans or IntelliJ or something like that, those are all quote-unquote project-oriented build environments. Second one is convention over configuration. So this is kind of the intelligence piece that I was talking about before. Again, Maven assumes that we can be smart about software development. It takes the approach that when I need to change the general default structure, I can do that through some XML configuration. So that makes, from a project startup perspective, that makes my project startup a lot less in comparison to something like Ant. Maven also is focused on dependency management, and dependency management in the Java world seems like every year becomes more and more and more of a nuisance, and that's primarily because the proliferation of third-party libraries that we can use to simplify the development of our applications. So in Ant, if you're familiar with Ant, I had to do all of the dependency management myself. I had to create class paths, for example, in Ant, and define in my class path all of the jars that I would use to build my project. In the dependency management world, there are really kind of two two camps to be aware of. There is what I would call the external dependency, meaning my application relies on an external third-party library, like Apache Commons as an example, or the Spring Framework as an example. And then there is the internal dependency, and that means that my project is reliant upon some other project built within my same company. Maybe it's by a different team, maybe it's by a different developer, but whatever that project is, it's bundled up as a library and I can use it. The key thing to recognize here about Maven is that it will manage both the external dependencies and the internal dependencies associated with my project. And that is all performed through either external repositories or local repositories. Fourth focus of Maven is that Maven really is what we call a kind of a plug-in execution framework. And what I mean by that is that Maven in and of itself is just a piece of software that knows how to execute plugins, and those plugins know how to perform very specific goals. In Ant terminology, what we have is Maven is a framework that knows how to execute quote-unquote tasks. The reason this is important is that when I'm working with Maven, Maven doesn't have all of the functionality built into it required to, for example, perform unit testing. It's going to go out to an external dependency or external resource, download the external dependency, download the plugin to support that external dependency, and then invoke it dynamically. So these plugins, the plugin nature is all dynamic. And then the last piece there is the repositories, which we kind of talked about in the context of dependency management. In the real world, when I'm working with Maven, if I'm coming from Ant, you will right away see that Maven is a lot simpler to use. You'll also find that it's very oriented instead of task oriented. One thing that's going to be potentially a little bit different is this idea of a life cycle. So because Maven is trying to bridge the gap between those full-featured project lifecycle management tools and standard build tools, Maven adopts some of that lifecycle terminology. So that may be slightly different or might be slightly new for you to grab onto. But it really shouldn't affect how we use Maven or how we think of Maven. For the most part, it's pretty straightforward. Because Maven is a build tool, and we are trying to have a build that works across every single platform, kind of with like the promise of Java. The project structure or the build structure is defined in an XML file. That's called the POM. The POM, if you were to look at it, looks and feels like just like any other XML file. The way that Maven works with the POM is slightly different than maybe some other XML-oriented build tools. In general, what happens is that Maven pulls in the POM in memory, creates an object, quote-unquote, an object from that POM, and that object you'll see in the last point there is extended from the super POM. So there is some inherent inheritance built into Maven, and that's important for us to recognize because from a development perspective, the super POM provides a lot of capability out of the box that we never have to worry about. In other words, it optimizes the project for us. So let me just quick pause for a second. Are there any questions on those first few slides that we've gone through?
Actually, I have a question about the super POM.
Okay.
What designates it as being the super POM? Is it the POM at the root level of the project?
Yeah, that's a good question. There is when you download and install Maven, which you'll have an opportunity to do in a minute, in the jar file that represents Maven, there is a pom.xml file.
Okay.
And the fact that it lives in that jar makes it the quote-unquote super POM.
Oh, okay. Got it.
Does that make sense?
Yes.
Okay. Yeah, so it's not like I have to go build that myself and then manage that myself. Somebody else, some developer who's working on the Maven project has done that for me.
So would it be like the equivalent of the object class in Java or something like that?
Exactly. Yep.
Okay.
Yeah, and I mean that's a good analogy. That if I wanted to theoretically change the functionality of the object class in Java, right, I could go unpackage or unbundle the jar rt.jar, put in my own java.lang.object, move on with life. I could do the same type of thing with Maven. It's generally frowned upon in both scenarios, but yep, good question. Other questions? Okay, so let's just quick look at the difference between Ant and Maven. And again, maybe this is poor on my end, but I've kind of assumed that if you're a Java developer, you have to be familiar with Ant. So what you'll see in front of you here are two examples. The one in tan or light tan is an example of an Ant build file. The one in white is an example of a Maven POM file. And what I want you to notice, just is purely the number of lines of code that is required for me to build an Ant script versus a Maven POM. We could argue a little bit about whether or not the line number count is accurate, since the build.xml does have some comments in there. But even if we were to take those away, maybe my Ant script is a factor of 4 versus a factor of 5 in terms of size. The other thing to recognize is that you'll notice if you were to look at the Maven POM, there's no real configuration about the project. It's just what I would call kind of some naming information. So let's look at this comparison in a little bit more detail. What I want you to recognize is that in the Maven world, something like 80% of the configuration for a project is automatically defined. Where in the Ant world, get really fancy with my Ant build script and create build scripts that derive from other build scripts. Nearly everything is manual. So for us, when we went to create our most basic POM, all that we really needed to do was to define some project information. And really the project information that we provided was kind of the project name. And that, we'll get to that in a little while later on, but that project name, so to speak, really is, in Maven terminology, the UUID. So the only thing that I really have to configure is the UUID for my project. And the reason that I have to configure that is because, remember, Maven does this automatic dependency management for me. And so when Maven tries to find a project and manage its dependency, it needs some unique identifier. So that it all kind of makes logical sense. But the rest of the stuff, directory structure, library dependencies, how I'm going to compile, what version of the compiler I'm going to use, the target platform, for example, when I build my .class files, the test framework, whether I'm using TestNG or JUnit, how I'm going to package something, whether it's a jar or war, how I'm going to do versioning, dot releases, for example, how I'm going to deployment, all that stuff, for the most part, is pre-built into Maven. So the key thing there, again, is that I don't have to build those tasks into my pom.xml file. If anything, all that I would have to do is change the configuration of one of those tasks. So it's a lot easier to work with. So just in comparison, again, if we went back to this source code example, the key point is that I am just specifying kind of my kind of my my project information, and that we'll talk about that in some more detail in the future. But that's really defined in the UUID. So in the last 20 or so minutes, we just quickly walk through at a high level what Maven is. We talked about it, how it takes on that project management perspective. It's focused on projects, not tasks. We also mentioned how it simplifies the build process by using defaults versus or intelligent defaults versus me manually configuring everything. And then obviously the last point there is that it is an alternative to Ant. The key thing for you to be aware of as an adopter of Maven is that I do not have to fully abandon Ant to work with Maven. In other words, there is a plugin for Maven called the Ant plugin that allows Maven to execute Ant tasks. So if I have an existing Ant script that's been around in my organization for 3 years, and I don't want to completely abandon it, but I want to start down the adoption curve of Maven, I could do that and then have Maven kind of call out to that script as needed. So it's a good way to kind of ease the transition from one build framework to another build framework. So now that we have the context for Maven, let's just talk about how we as a group can get Maven going in our environments. So we're going to talk about kind of what we need to do to set up your environment, some of the key commands that you should be familiar with in Maven to work with Maven from the command line, and then we'll finish up this section with kind of you creating your first Maven project. So setting up the environment, Maven is a Java tool. So what that means is that you as a developer need to have Java installed. You're going to need to have the JDK installed instead of just the plain old Java SE. And the primary reason there is that the compiler plugin relies on Java C, which obviously isn't in the just Java at runtime environment. So you need to have the JDK installed. Over the years, certain tools have moved away from the dependency on Java_home. Some tools still require it. Tomcat, for example, still requires it. Maven, for example, still requires it. So from the command line, you'll want to make sure that you set up an environment variable for Java_home. And hopefully, at this point in everybody's Java career, you can do that without too many issues. Second thing is that you do need an internet connection, a live internet connection. And the reason this is important, again, is that Maven is doing this external dependency management for us. And when Maven goes to resolve an external dependency, the first thing it's going to do is it's going to look at its local cache. And, first time I install Maven, there's going to be virtually nothing in my local cache from a dependency perspective. And then after Maven queries the local cache for the dependencies, when it discovers that the dependency does not exist, Maven is going to go out to an external repository. It's called the central repository, and try to find in that central repository the dependencies, and then download those dependencies dynamically. So if you don't have a live internet connection, what's going to happen is that Maven's going to fail when it tries to download those dependencies. And so obviously you won't be able to get that very cool dynamic dependency management feature. To grab and download Maven, obviously you guys have to pick which version of Maven you're going to work with. Just go to maven.apache.org, grab the zip file, extract the zip file. Usually in the Unix/Linux world, people put Maven in user local Maven. In Windows, it's kind of up to you. my personal tendency is to put non-executable, treat a non-executable as if it were an executable. So in other words, usually put Maven in the program files directory. But again, that's entirely up to you. Obviously, once you download, extract Maven to the correct place, there are some steps that you need to go through so that you can use Maven in the command line. First thing you need to do is you need to configure M2 home. So this is assuming that we're using Maven 2. Maven as a tool is going to expect that this environment variable exists. So if you, for example, had Java Home set up and you had Maven, the Maven executable in your path, and you were to run the mvn command, Maven's going to come back and say, hold on just a minute, M2 Home's not defined. So you've got to define that. And again, I would assume everybody knows how to set up an environment variable in either the Unix, Linux world or Windows. And then modifying the path. So however you want to configure the path, if you want Maven to be the first thing in the path or the last thing in the path, or that's entirely up to you. I will say that on certain operating systems, the Mac, Mac OS X, Maven is bundled with the operating system. So if you wanted to use a new version of Maven than the one that's bundled in the system, you're going to have to play around with the path a little bit. But that, again, shouldn't be a big deal. Obviously, like everything, when I'm setting up environment variables, I can either do them in the command line while I'm working in the shell, or I can set up something at a system level, dot profile, for example, something like that, so that those environment variables are always there in the shell. So assuming that I have download, extracted, configured my environment, then theoretically the Maven tool should be able to me. An easy way for us to test it is to do Maven-V, so verbose. It just tells us some version information about Maven. You can see here that I'm running Maven on a Mac, and shows you some information about my Mac, but also shows you some information about the Maven version that I'm using. Once I have validated that the installation works, as a developer, I always personally want to know what in the heck did I just install, because I just added something to my disk that something takes up disk space. Do I need it all? I don't know. But from an installation perspective, you'll see that Maven Maven is a pretty small quote-unquote install. It's kind of what you would expect for a Java library. Since I'm trying to treat Maven as an executable, I need some type of shell or some script. That script is going to kick off this Maven application. That Maven application is going to have some dependencies on a library and some configuration. So the rest of this licensing information, README information, so on and so forth, and that's pretty typical when we download a library from the web. So that I'll talk about a couple of seconds, just so that so everybody's clear. Remember, one of the key advantages of using Maven. Yeah, Derek, you have a. Hold on, let me unmute you. Yes, you have.
Yeah, your voice is kind of breaking up here. I don't know if it's our end or your end, but we're missing a lot of what you're saying.
It is for me too, Galby. So,
is it breaking up continually or sporadically?
Continuously, sort of kind of sound.
Okay. All right. So let me stop the recording for a second. Back in. So when I
Thank you. Please stand by.